Very nice. The people with the budget. So we are trying to build a whole host of models that essentially fill that Opus 4.6 fast bucket. Like what would you do if you could get 2 times, 3 times, 5 times as much performance out of the same exact AI models that you guys use today? And hopefully, what I would want to go through, if the connector works, is the techniques that we apply in order to optimize these models. And then beyond that, do a live demo and show some of the internal software that we use to optimize these models automatically. What's going on?
Just 1 second.
We're up.
Display. It's good? Okay. This one?
Yeah, that's good. Let's go full screen. Cool. So, we're live. Ultra-fast inference endpoints. Essentially, we break out optimization into 5 key layers. At the bottom layer is the hardware itself. NVIDIA H100, NVIDIA B200, AMD, TPU, Trainium, a whole bunch of different ASICs are possible to mess with too. Especially if you look at like where we were about a year ago and where we are today and where things are clearly going, we're clearly heading into a more heterogeneous world, meaning we're starting to use combinations of hardware architectures. NVIDIA actually confirmed this when they acquired Grok, their largest acquisition ever, for $20 billion. Grok is an alternative architecture. And this is NVIDIA, the king of AI hardware, saying yes, there are other architectures that are better at certain things. So this is something that we see coming in the future. To enable alternative architectures, we're going to need low-level software called kernels that actually map algorithms to that hardware. Instead of writing kernels manually, we've developed a bunch of coding agents that can help us do this automatically. And we can generate kernels for a very wide variety of hardware, including Tenstorrent, Qualcomm, TPU, AMD, and NVIDIA. All of this goes into inference engines like VLLM, SGLang, or any other type of inference engine. These engines alone also have different types of optimizations that you can apply. And then lastly, we do a lot of novel algorithmic optimizations. So this is a bit of research that came from our team. We developed a speculative decoding technique called sequential Monte Carlo speculative decoding. This is nice because it actually almost does test time scaling as part of the speculator. A really surprising result is that we can actually get faster performance here and get higher accuracy than the target model on its own. The results are strong. We have a number of models that are ranking #1 in performance on artificial analysis, an independent third-party benchmark. We have the fastest DeepSeek V4 Flash. We have the fastest DeepSeek V4 Pro. We have a couple Quen models that are really fast, and then we have a Llama 70
Your agent already
#1. This is just a short video showing how much faster you can actually be. This is with the sequential Monte Carlo speculative decoding. And so if you have an application or if you're using a coding agent iteratively, you can imagine what you might be able to do with an extra, 4x performance improvement. And now I will show you like the actual software, if I can. There we go. So this is what our internal software platform looks like. What's really exciting about this is that a lot of these experiments actually happen automatically. And so what I'm showing you is our DeepSeek V4 Flash optimization process. It starts with a baseline. We set the optimization target, and then the agent starts running different experiments. It runs experiments across, hyperparameter sweeping, and then as low level as kernel optimization for specific workloads. You'll see like a detailed overview of what each experiment does. You can collaborate and propose your own experiments. And ultimately, you end up with a nice Pareto curve. So this gives us the ability to deploy either the fastest token per second per user implementation or the highest throughput implementation. And ultimately, what we do deploy ends up on our website. And this is accessible via API, via curl, via whatever else you want to use. And then you end up with really fast DeepSeek V4 Pro. So here we are getting about 300 tokens per second. And if you compare that to like OpenRouter, for example, The average you're seeing is around 85 for the high end, but most providers are actually somewhere between 20 and 50 tokens per second. So the question is, like, what can you do with an extra 4x performance on DeepSeek v4? And that's the type of work that our team gets into. So the bottom line is that we think that tokens per second is ultimately some corollary to intelligence per second. And if you can double the tokens per second, we're going to see an improvement in intelligence per second in individual applications, a bump in productivity, and ultimately we want to open up the possibility for a lot more types of applications. Instead of waiting 10 minutes for that presentation to get generated, what if you only had to wait 2 minutes or 1 minute or 15 seconds? How much more work could you get done? So that is what Makora does. The platform is available today. You can try it online, and then we have a bunch of free promos and stuff going on too. So thank you guys for having me. Thank you for indulging me. And if you want to talk performance engineering, kernels, or anything else, find me after this. Thank you.